Hi, in this demo I will show you how to transform data interactively, which is usually called data preparation. We will use the Practicus AI app for most of the features. And I will also show how to use Excel to transform data and turn it into data preparation steps. I will use a data lake for this demo, which is on S3. You can type the bucket name to browse, or you can load to see all the buckets known to this account. I only have one bucket for this account. I can also choose a different cloud configuration or simply enter credentials for a different account that my current user does not have access to. Using the Navigate section, you can easily view the objects on the S3 bucket as if they are files on your laptop and can copy, paste, upload, download files. Let me expand Boston 1 billion folder and click on a file. You will immediately get a small sample and an estimation of total rows. This file has around 17 million rows. You can navigate different files. The estimations and the navigate section will refresh immediately. Now let me click the Boston folder. Since the files have a similar structure, I will get a total rows estimation of all the files combined. We could have several layers of child folders and this would still work. I will read 1 million random rows. If you're a technical user, you can also click Advanced and choose a different sample size for the cloud node. Normally, the cloud node keeps the same number of samples as the app. In this case, I would keep 1,000 times more rows in the cloud, which is 1 billion rows, and just 1 million on the app. When we make interactive changes on the data, the app and the cloud node work asynchronous. The app would make changes and move on. Even if the changes on the 1 billion rows takes longer to complete, the user would not have to wait for this to complete, improving the user experience. We will discuss more about the async nature in a few minutes. You can also choose a different processing engine. If you use a larger cloud capacity with many CPUs, choosing Dask will significantly improve performance. For GPUs, you can use Rapids or Rapids and Dask if you want to utilize parallel GPUs. With sufficient cloud capacity, you can easily transform billions of rows interactively. To learn more about cloud capacity, please view the operations demo video. If you are not a technical user, leaving the defaults will have enough cloud capacity for most tasks. For this demo, I will keep it simple and will read 1 million random rows. As you can see, in around 4 seconds, we were able to scan more than 1 billion rows on S3 and get a random sample of 1 million. Let's start making some changes on this dataset. Let me delete some columns and apply some filters. For instance, I can filter outliers using the histogram. You can also create more complex filter statements using the filter dialog. You can also author more complex statements using brackets and or statements as well. The filter is applied. If I click on a cell, you can change the value to make corrections which will apply to the entire column, or you can apply some filters quickly as well. The most common data preparation operations are in the section called Data Prep. Now let's take a look at Formula Dialog. We have more than 200 Excel-style functions available. What I mean by Excel style is that the function parameters are the same. If you can use them in Excel, you can use it here as is. Let me search for square root. Before I add this function, I can also test its result. As you can see, navigating between rows will show me the result right away. Let me add this. You can add new functions by typing as well. And test the result of the final formula before applying. And we will see the results right away. If you're more familiar with Python coding, you can click Add UDF button, which stands for User Defined Function, and you will get a simple Python editor to define the UDF and test its code. UDFs are row-based. Let me show you a more advanced option. This is a simple editor where you can author more advanced Python code. Let me click Test, which will run my code on a small sample size, and I will click OK, which will work on the entire dataset. Let's say you're working with someone who, for some reason, cannot use Practicus AI app for data preparation. Similar to using Excel for AI predictions, we also offer the ability to use Excel for data preparation. We call this Excel Prep. As explained in this dialog, the way Excel Prep works is extremely simple. Export the data, make changes, and then we will detect those changes and apply to the original data source. Let me start with exporting some data to Excel. And let's assume I emailed this file to a team member who only uses Excel or Google Sheets. They can then open the file and start making changes. I will delete some columns. Add some more filters. And also make a change. Let's say I found an error. We don't have to change every wrong value. It is okay if you do, but changing only one will be enough. And let's add a formula. Let's say if the value of this is greater than 20, get B or else that. We detect more than 200 Excel functions. Now, let's assume our team member saved the Excel file and emailed it back to me a few days later. We would then open the worksheet and then come to Excel Prep and then import the file. The changes are detected. I can now review them, update if I must, and then accept. For instance, you can change the formula code. If you're a technical user, you can also make changes to the detected steps code. You can do this through our SDK as well. Clicking OK will apply all the steps. All of the changes we have made so far, including the ones that come from Excel, can be viewed in the Steps dialog. Let's say I want to make a change to my custom code. We can also quickly undo and redo changes using the menu or just the shortcuts. Undo one more time, and then redo, and redo. Now, let's say I want to export the data and share with others. The simplest way would be to click Save and then Export Data, and then I can select a destination, say back to S3 or a database, and then click OK. Since I'm using the optional cloud node in this demo, what gets exported would be the dataset in the cloud. And if I have a different sample size, say a billion in the cloud versus 1 million rows in the app, what gets exported would be the billion. An alternative to data export is applying steps. For instance, in this demo, we designed our data preparation steps using S3. We can come to this dialog and then choose, say, Snowflake to read the data from, and then another destination, for instance, Redshift, and then clicking OK would load the data from the source, Snowflake, apply all the steps, and then save the resulting dataset to Redshift. Lastly, saving a worksheet is exactly what you would expect. We save all the steps, including where and how we read the data, to a file so you can share with others, and then they can open up this file, load updated data, run all the steps to transform, and then export final fresh data to a new destination whenever they need to. Using Practicus AI app to prepare fresh data is a great option for ad hoc experimentation. However, this can easily become a major burden if you need to keep repeating this operation. A much better alternative would be to create an automated data and AI pipeline. I will show how you can do this and more in the next operations demo video.